Precalc, Chapter 1, Section 6. It's all about inverses. So we're going to find inverses, talk about one-to-one relationship, find it through graphing and algebraic methods. So first of all, let's talk about what an inverse is. So an inverse, the notation is f to the negative 1, is a mapping from set B to set A. So if you remember our definition for what a function is, we're going from set A to set B. The inverse is from set B to set A. Or we are mapping from the range to the domain. So we are switching the order we do that. So in the notation we have f to the negative 1 is an inverse function of f if and only if. So that double f is on purpose. It means if and only if. So it goes both ways. So the inverse of f is a function of f if f of g of x equals x and if g of f of x equals x. So you have to check both of these to make sure that they are inverses. And so a key word here is verify. So you need to complete this right here whenever you see the word verify. That key word there, verify, says you should do the composition both ways to show that they are inverses. So really all we're doing is taking the range and the domain and we're flipping spots. So algebraically, we can find inverse algebraically just by placing the y in for f of x. So it helps us with solving. So instead of having f of x, we just use one variable y. Then you just switch the x and y. That's the big thing. Switching x and y is the main definition for inverses, because what you're doing here is you're switching the domain and range, which is the definition of the inverse. We're going to re-alter the order of the or the mapping. So solve for y. We like solved in terms of y. And then we can replace the y with the inverse function notation, and then you can verify to make sure that those are inverses. And so down here, let's find the inverse of this function. So we have f of x equals 4x minus 1. We want to find the inverse. Let's first rewrite it with y, just so we have less notation to write. Then we're going to switch the x and y. So when I rewrite it again, I'll place the x and y's and flip them. So usually I'll skip that first step and I'll go right from here to here, just replacing that f of x with y. Now I have to solve for y. So this goes back to your basic algebra skills of how to isolate y. So you always want to get rid of the addition subtraction first. So we end up with x plus 1 equals 4y. And then we still want to divide both sides by 4. So we have y is equal to x plus 1 over 4, which we could write that. Let's first use the notation f to the negative 1 as a notation saying that it is the inverse. And we could write that as x over 4 plus 1 over 4, split that as two fractions, or even better, what most students would prefer is rewrite it as 1/4 x plus 1/4. So that's how I'll leave that. So those would be inverses. And what's the point of an inverse function? So this first function here, this equation here, it does something to x. So if I put a number in for x, let's put in a number, let's put in 2. If I put 2 in, then I find f of 2 would be, so 4 times 2 is 8, 8 minus 1 is 7. So f of 2 is 7. So if x is the 2, then the y is 7. So that function did something to our number 2, it turns it into number 7. The inverse function, if we take the result we get, we take the 7 and we plug it into the inverse function and then figure out what happens. So it's going to be 1/4 times 7 plus 1/4. So that's really going to be 7/4 plus 1/4, which is 8/4, which is 2. So for this one, if we plugged in 7 for x, then we find the inverse function is 2, which was our beginning value. That always happens with inverses. It undoes what was happening. So here's another example of what inverses does, and it may make more sense. If we take a wash machine, and we put in a dirty shirt. So take a shirt, we put it in, it's dirty. It comes out clean. Now if we put it into the inverse function, we put that clean shirt in, how does it come out? It comes back out dirty. So dirty, clean, clean, dirty, it undoes what happens. That's what an inverse function does to the original function. Now here's that word verify again. To verify. Whenever you see that, you have to check that the f of the inverse of f of x is equal to x, and the inverse of f of x is also equal to x. And the point of this is you're really checking to see if it's undoing itself. You're checking to see if that first function will undo, or the second function undoes the first function's math. Let's verify with these two functions down here. So we're going to find the f of the inverse of x. So if I take the function f of x, which is 4, whatever x is, minus 1. So 4x minus 1 was the original f of x. We need to replace the x with the inverse function, which is the 1/4 x plus 1/4. So now we just have to simplify this. So we distribute the 4 through here. If you do that, you get x plus 1 minus the 1, which we add those, we just get x. So let's show the opposite is also true, where we put the f of x into the function of the inverse. So the inverse function is the 1/4 x plus 1/4, and our x value here was the original function here, the 4x minus 1. So 4x minus 1. We distribute the 1/4, we get x minus 1/4 plus 1/4, which again is just x. So we're showing that they both are equal to x, which is what we do for verifying that two things are inverses. So we can also do this graphically. Graphically is pretty easy. All the points f of x. So f of x like y, so we have the point xy or f of x. All you do is the points become f of xx. So another way is saying you switch the domain range. You switch the x and y's. So given f of x is the inverse of a function. So if you don't want to actually graph the new one, you can find out if the inverse is a function by looking at the original function. To do that, we just use the horizontal line test. So the horizontal line test to find if the graph is 1-to-1, which means the inverse is a function. So 1-to-1 is not talking about the function. 1-to-1 is talking about the inverse. This lets us know about the inverse function. So if we're given a graph here, this graph, it's like a cubic graph. If we draw a horizontal line through it, it hits more than one point. Because it does that, because it hits more than one point, then we know it's not 1-to-1. If it's not 1-to-1, then we know it's not, the inverse is not a function. So it's not 1-to-1, so the inverse is not a function. That's the whole point of 1-to-1 in the horizontal line test. The vertical line test tells us if this is a function, which this one is. The horizontal line tells us is the inverse of a function. So if I give you a graph, let's do one here. If I just pick some points here, I'll kind of make it cubic again. So we have this. I'm going to call this point right here, assuming I hit it, -3, 1. Let's call this point here 0, 3. This point here, let's do 1, 2. And then let's do 3, 5. Now I'm just making this up. So if I want to find the inverse, I take these points and I flip it. So -3, 1, that point will become 1, -3. That's where it goes. 0, 3 would become 3, 0. 1, 2 becomes 2, 1. And 3, 5 becomes 5, 3. So then I'd end up with this function. Instead of the inverse function. So you just basically switch the x and the y's, replot the point, that's the inverse point. So let's find the inverse of this one. The square root of x plus 4 minus 2. So we're going to find the inverse algebraically. We're just going to switch the x and the y. So we're going to put the x equals the square root of y plus 4 minus 2. So then we need to isolate y, so I'll add 2 to both sides. Square root of y plus 4. And now, to get y by itself, we have to remember how to get rid of this root, square root, you get rid of by squaring both sides. So when we square both sides, the right side is pretty easy. We just get y plus 4. But the left side is a little more difficult. We get x squared, not plus 4, plus 4x plus 4. We get the trinomial, so you have to FOIL that. Then I can subtract the 4, so you have x squared plus 4x equals y. So that would be the inverse function. So the inverse function of x is equal to x squared plus 4x. Not too bad. But this problem is not done yet. And here's the reason why. Let's go back to the original one. If we look at the original function here, we need to think about this for a second, because we should realize that there is a domain for this. We've got to be careful. We've got to take the square root of a positive, so we need x to be greater than or equal to -4, which I could also write that using our interval notation from -4 to positive infinity. The range, if I think about when we talk about graphing these, our shift, we go left 4, and down 2. That's where we started, and it has this shape to it. So we're going to go above it, above -2. So I know my range is from -2 to positive infinity. And so this is domain and range for the function f. This is for f of x. So what would it be for the inverse? And you look at the equation, you think, oh, that's not too bad. That can be anything at once. But realize that it comes from the inverse, where we switch the domain and the range. So our range of the original one becomes the domain of the next one. So it becomes the domain. The domain gives us our range of the other one. So they flip. Now why is this? Because if we look at the graph, the original graph of f of x, it's not a parabola. It's a square root. It's half the parabola. So when we actually graph this, the inverse, -2, -4 down here, we're only going to have half of a parabola. And so if we take this quadratic and then graph it, you're going to get a parabola similar to what we're graphing, but we only want the right hand side of it. So by giving us the domain and range here, we're going to restrict it to only have the right hand side, because that's all we had to start with in the function. The f of x function is not all the points to make a parabola when you find the inverse. So we have to keep it restricted. So there's the domain and range for the inverse. So it's very crucial when we find inverses that you realize that domain and range just switch spots. Not even the x and y's is not enough. The x and y switch, and so do the domain and ranges. That's it for 1-6. So have a great night. We'll see you tomorrow.